Today I'm going to describe a project I did that I had wanted to do for a long time now and finally had the time to do it. It is a radar speed camera, and for more than a few years now the speeders on my street have been a problem, and I wanted to start recording who they are and what their speeds are. What is it made with? Well, these are commonly available and not very costly items. In particular, I used a Bushnell Sport radar that I had for a number of years, hacked it, and married it to a Raspberry Pi Model 3 running Ubuntu Mate. The key to this is a Pi camera with a CS mounted telephoto lens. I wrote the executable in C++, and importantly I used the OpenCV library along with the Pi GPIO library, and it involved developing some very simple circuitry. When a car passes into the radar beam, the Pi starts capturing images. When the car is centered in the field of view, that particular image is saved. Also, as the car is passing through the radar beam, speeds are being measured, and the maximum speed that is measured is retained for later saving. Finally, the image with a file name containing a timestamp and the speed is saved, and before it's saved, the speed is added to the image so that one can conveniently view that image and know what the speed is. So here's an overview of the system. Comprises all the elements I mentioned. On the lab stand, one sees the handheld Bushnell radar mounted. This is a K-band unit, which provides a reasonably narrow beam without significant side lobes. At the base, one sees the Raspberry Pi with the camera mounted, telephoto lens sticking out there. And then finally on the right there are two power supplies, wall chargers, that are providing 5 volts to the camera and 5 volts to the Pi and 5 volts to the Bushnell radar. Here's a bit more detail of the elements. Starting near the top, one sees a wire hanging out of the Bushnell radar, and that is a pair of wires which jumper over the handheld trigger, and when you jumper that with a jumper, the gun diode will remain oscillating continuously. Moving down below that is labeled a comparator with the variable reference level. This is a very simple circuit, and what it does will be described later. It's doing a little bit of processing of the audio Doppler frequencies that are coming out of the gun. And in order to run this thing, over to the right is a 5 to 3.3 volt converter, which is spliced into the 5 volt charger line. The Bushnell radar runs on 2 C-cell batteries, which provide essentially 3.2 volts, so one has to down convert the 5 volts to satisfy this. There's an optional relay board for the gun diode if one wants to programmatically turn the gun on and off. I developed this and put it there, but you'll see that it's not really needed to be used. Finally, I used a commercial GPIO breakout board to make the wiring easy and somewhat organized. So here's a picture showing the setup during testing. The radar unit is pointed up the street to a location as shown there, as you can see, and the telephoto on the Raspberry Pi is pointed to essentially the same location, and the setup, which will be shown, the result will be shown in just a moment, provides a field of view of a certain size. And please note that the all of this is offset 30 degrees from the line of travel of cars coming down the street. So simply speaking, the measured speeds have to be divided by the cosine of 30 degrees in order to get the actual forward speed of the vehicles. So here's the result, and you see the field of view is limited to what you see there. The speed of this vehicle is printed up in the left-hand corner. Notice that the license plate is readable, and the car is more or less centered in the field of view. All of this requires a bit of setup, and towards the end of this presentation I'll go into more detail on this.